Good evening. In this session, we are going to discuss about the OM microcontroller. So, first of all, we should know the OM stands for Advanced RISC Machine, and basically, it is available as a 32-bit RISC microcontroller. It was first introduced by the Akron Computers Organization in 1987. Like other microcontrollers, the OM is also a family of microcontroller architecture, and this patent has been brought by this patent has been bought by some chip designers, and they are manufacturing microcontrollers such as ST and NST, NXP, etc. Basically, the OM comes with the different versions, as each version has its own merit and demerit. The OM processor family maintains its own design from 1987, when they have started their OM microcontroller basics design. So this is the architecture of OM microcontroller. The OM is having different variants available in the commercial market, but the OM Cortex family, which developed by the OM V7 architecture. This is again divided into three subfamilies like OM Cortex series, OM Cortex RX series, OM Cortex MS series. So now coming to the architecture of ARM, the Cortex M3 processor is a high performance low cost 32-bit processor. This is consists three-stage pipeline to fetch, decode and execute the instructions. The Cortex series processor, or the cost sensitive device, which is used to reduce the delay and has extensive NVIC interrupt handling and system debug capability. The Cortex M3 ARM processors are implemented by the thumb instruction sets by thumb 1 on thumb 2 technology. Therefore, it ensures high code density and reduces the program memory requirement. The Cortex M3 instruction set provides excellent performance due to modern 32-bit architecture. The ARM processor core M3 is closely integrated to nested vector interrupts controller, that is NVIC, to provide a good interrupt performance. So here we can see the ARM core structure like NVIC, instruction fetch, three functions like fetch, decode and memory interface, then register bank, DAP, memory protection unit, then like bus matrix, data watch point, flash patch, then bus matrix, like ROM memory and SRAM memory. So this is the basic fundamental ARM architecture, which consists of blocks like arithmetic logic unit, booth multiplier, barrel shifter, control unit and register file. These are the main blocks of our ARM architecture. So arithmetic logic unit, we all very well know, it has 32 bits input, and it is used to operate all arithmetic and logic functions like arithmetic addition, subtraction and multiplications, division functions, and logic functions like and, or, not, all logic operations we can use in arithmetic logic unit. Booth multiplier factor has 332 bits inputs and output. It is a register file. The multiplier output is barely significant bits of the merchant side. So whenever the beginning input, the 04 input goes active, the fin of the output goes high when finishing. So this is all about our booth multiplier, and booth algorithm is also a noteworthy multiplication algorithm. It is one of the two's complement numbers. Then the figure, we can also see a booth algorithm like barrel shift features as 32-bit input, which is to be shifted, and the quantity by which the register ought to be shifted is immediately filled within the instruction, or it might be the lower up to 6 bits within the register file. So the shift type indicates the needed shift short of 0001 1011 to corresponding shift left or shift right and rotate right respectively. So the barrel shifter is especially created with multiplexers. And at last, control unit is used to control the entire system of the processor. For any processor, control unit is considered as the heart of the whole processor. So the processor timing and everything is included within this timing signals, and everything is included within the control unit. The signals from the control unit are also connected to each component within the processor to supervise its operation. So this is the functional block diagram of ARM, where you can see the ports, clocks, interrupts, bus controls, power, then memory interfaces, memory management interface, then coprocessor interfaces. So here we also have registers in ARM, like general purpose registers and special function registers. The ARM 7 is a load and store architecture, where if you want to perform any data processing instructions, then the first data has to move from a memory store into a set of central registers. So the data processing instruction has to be executed, and then the data again stored back into the memory. So this is all about the registers, and we have two types here. And register modes like user mode, FAQ, then IRQ, SVC mode, undefined mode, about mode, and monitor mode. And these are the types of modes, how it is represented. So explanation about all these modes. Some of the registers are reserved in each mode for the specific use of the code. So these are the registers like CPSR, SPSR, PC, general purpose, and special functions. And LPC 2148 microcontroller is also a widely used microcontroller from the ARM 7 family. So this is the structure of the same. So here we also has to we need to also think about our stack pointer, program counter, etc., and how to program a ARM Cortex microcontroller programming. See, this is the format, syntax format using assembler language, which converts the high level into low level. Okay. Yes, thank you.